am Mario Rangel, and today my group of statistics and me are going to talk about the probability. The probability have many cases or many different types to calculate it. The first one is the compatible events, the second one is the dependent events, the third is independent events, the fourth is mutually exclusive, the fifth is a conditional probability, and the last one is the bias theorem. Well, like I said, first I'm gonna tell you what is a compatible event. Well, now I'm gonna explain what is the compatible events or compatible success. Well, a compatible event is those that have elementary events. For example, the event A is when you have a dice or a money, and what is the probability that you obtain a pair number in the case of the dice, or the face in the case of the money. This is the event A. In the event B, could be what is the probability to obtain a multiple of 3 in the dice or the stamp in the money. Well, the way to calculate the probability of that is using a formula. That formula is probability of A plus probability of B minus probability of A plus B. Well, now we're gonna do an exercise. For example, I threw this dice, and for example, what is the probability to obtain a per number, and the probability to obtain a number higher than 3? Well, I have to use the formula and have. And this is the solution of this exercise.
Tumba la casa, mami. Tumba la casa, mami.
Hello teacher and friends, my name is Jose Manuel Borja and I'm going to explain to you the depend success. The depend success are those where the result depend on other. That is, where the first probability shows a result, the second will depend in this first probability. To understand easier, I'm going to show to you an example. I'm going to show to you this example, so to understand much better. Well, here this case of probability show us the 5 balls. 3 are in color violet and 2 in color red. So what is the probability if I'm going to draw out one violet color? That is 3/5, 3 colors of violet over the 5, that is all. And in the red color is 2/5, because we have 2 of red and 5 in all. To continue the exercise, there are 2 cases. When I draw out the color violet, we only have 4 colors. So if I going to continue the exercise to show us to take another violet color, we have 2/4, because with the color that we draw it out before, we only have 4, and the result is 2 violet and 2 red, and we have 2/4 with the all. And in the part we to take and draw out one color red, we have 2/4, like the same of the violet. And in the other case, if if I going to draw out the red color, we only have the same 4, but 3 violet and 1 red. If I'm going to take another color, violet or red, in the case of violet, we have the probability 3/4 because we have the 3 violet and 4 with all. And in the red, we only have 1/4, 1 red, and the rest there are 4. Well, these results we going to show us in the formula. This formula is only to show the results, and this is 2 cases with the same, to show two balls with the same color, and this one to show to draw out 2 balls, but one with one color and the other with another color. Here if we only going to draw out 2 colors with the same, that is a purple, we have 3/5, that is the 5 balls, the 5 balls 3/5, and this 2 and this time 2/4. That is the result when I draw it out the for the violet ball, and this we have the probability 6/20, 3 times 2 and 5 times 4. In the another case, we have with the red ball, we have 2/5 and 1/4. That is the dependent of the before exercise. Here the result, but is 2/20, and here we have with different color 3/5 with the another case with another color. If I drop out the violet, and here the red 2/5 times with 3/4.
Ay, ya no me duele más, ya te logré olvidar, y aunque te quise tanto, tu recuerdo me hace mal.
Well, my name is Juan Camilo Fajardo. Sorry, Fajardo. Well, today I'm going to talk about the independent events in statistics. So, well, first of all, what is an independent event? Well, an independent event is when we have an event, yeah, and the probability of this event is the same as a next event. What I mean, that if we are gonna calculate the probability of this event, it's gonna be the same of this, because we are not gonna have this is not gonna be affected by this. For example, if we get a coin and we are playing like stamp and face, yeah, if we throw it and we get a stamp, the next time that we are gonna throw it, we're gonna get the same probability as the previous one. Why? Because the probability is not going to be affected by the previous one. That's the independent probability. Well, now I'm gonna show to you some examples of these independent events. So first, I'm gonna show the most classical one and the easiest one to understand. That is the dice one. Yeah. What happens with the dice? If we throw the dice, we have a probability of getting any number of 1/6. Now, what is interesting about the dice is that if we throw it again, we're going to have the same probability of getting any other number, so it would be 1/6 again. Now, why does it happen? It happens because if I throw the dice and if I get a number, let's say like 4, I'm going to have this probability. And if I throw it the second time and I get again a 4, it would be the same probability. So what we can conclude about this is that the first try is not affecting the second try. So we can say that it's independent. Yeah, because as I said before, the independent one is the when it doesn't matter what you did before, it's not gonna affect the second try. The second example of this conditional independence is the cards. Well, for this, we are gonna pick a random card, let's say this, and we are gonna say that the probability of getting this card is 1/52. Yeah. Now, what is interesting about this? If I get this card and I put it again right here, and I shuffle this, the probability of getting that card again would be 1 over 52. Why? Because I didn't remove the card from here, and it will remain the same. Now, if I get this card and I put it away, yeah, we would have a probability of 1 over 51. Why I'm explaining this? Because this event is dependent of this one. Why? Because I discarded that one. Now, if I don't discard it and I leave it right here again, it would be the same. Yeah, so 1 over 52. Now for this third example, I'm gonna put a situation. We have a bowl, and inside this bowl we have 3 orange balls and 2 purple ones. Now, if we are asked about what is the probability of getting an orange ball, it would be 3 over 5. Now, if we get one orange ball and we take it out, we would have this probability. And if we put it back again, and if we do this thing again, and if they ask us what is the probability of getting an orange ball again, it would be the same. Why? Because I put the orange ball again. Why? Because if I put it again, then it's not gonna depend on the previous one. Yeah, because if I leave the ball outside, the probability would be 2 over 5. And that's how dependent events work. So I think that's everything. Thanks for your attention.
La primera se desespera, se encojona si se lo echo afuera. La segunda tiene la funda y me paga pa' que se lo hunda. La tercera me quita el estrés, vuelvo corrido siempre echamos.
Alright, so hello everyone. I'm going to talk about the mutually exclusive events. So what are the mutually exclusive events? It is also known as the additive probability. And let's suppose that we have, I don't know, like a deck of cards like this, or a container of markers. So how do I use the mutually probability? So I want to know the probability of when I take a marker without ink, it's the red one. Yeah. So how do I do it? That's why I use the mutually exclusive probability, to know in one only possibility, in one only event. Yeah, this event can only happen once. Yeah, I don't know. I can use no. I want to know the probability to find the red marker and a card. No, it can be possible. Yeah, or is the marker or is the card? It can be both. So the mutually exclusive events are those events which can only happen one time. It cannot happen 2 times, like in the same way. So I'm gonna put you a little example in order to you to understand it. So here we have 8 markers, and I want to know, like I told you before, I want to know the probability of take the red one and the blue one. So how do I use? Here we have an example of how do you use the mutually exclusive events. So here is the probability of taking out the red marker from the container. So we have the red marker, there is 1, divided by the total number of elements in the container. We have 8 markers, so it is 8. Okay, so I repeat, the marker divided by all the elements in the container. This is the probability of the red marker. The blue marker is the same. Yeah, we have the blue marker, 1, divided by all the elements in the container, there is 8. So we have the probability of the red marker and the blue marker. So I want to know the probability of taking them both at the same time. So like it happened once. So the probability of taking the red marker or the blue marker is the probability of the red marker plus the probability of the blue marker. So the probability of taking the red marker or the blue marker is 2 divided by 8, that is the addition between the probabilities, that is equal to 1 divided by 4, that is equal by to 0.25, that is equal to 25%. 25% is the probability of taking the red marker or the blue marker. So I'm going to show you another example with the cards. With the cards, let's say we have here 40 cards, and I want to know the probability of taking card number 2 and card number 5. So here is the probability of taking the card number 2 with the number 2. So this is a little more difficult example because the number 2 repeats at the first time. Is when I take an element from a group, I want to take the red marker, so I calculate the probability of taking the red marker or the blue marker, or of taking the yellow marker with the green marker. Yeah, it's about taking two elements of one single group in order to find the probability of taking out two elements from my group. Thank you.
Simón dice, que se muevan pa' la orilla cuando yo aterrice. Simón dice, que la pizza está moja, cuidado no se deslice. Simón dice, imitan mi flow y nadie lo descubre. Simón dice, que vamos a romper el chorizo el 10 de octubre. Un segundo y demostrarte que estás escuchando al real dueño del arte en relación con mis...
Well, in this exercise, we have a company that has a percentage of his employees. For example, the 20% of the engineers, and of this 20%, the 70% of it have a direct charge. In the economy area, the 20% of it has a 50% of this 20% in a direct charge, and the other employees are 60%, with his employees of this 60% have a direct charge. And the question are, which is the probability to select randomly an engineer that at the same time is in a direct charge? Well, now to solve this exercise, we need to use the theorem of patches. Now, is the probability to have over the line the percentage of the engineers times the percentage of directives of engineers that have the directive charge. Represented in decimal number is 0.2, that is 20%, times 0.75, that is 75%. And under the line, that is all the probabilities. The same of the engineers, the economy ones, and the other ones. The engineer ones is the same, 0.2 times 0.75 plus 0.2 times 0.5 plus the others, that is 0.6 plus 0.2, that is 20%. Now the probability is, with the calculator, the real calculator, 0.2 plus times 0.75 is 0.15. Now 0.15, that is the same that's under the line, plus 0.2 plus 0.5, 0.1, and plus 0.6 plus 0.2, that is 0.12. And now the probability is that is 0.37 with all these results. Now 0.15 divided 0.37, that is 0.40, and now is the 40.5%.
Cuando conmigo, mami, chocas. Chaca, 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 chocas. Y te muerde la boca, mami.
I'm going to explain to you a little bit about the conditional probability. In probability theory, the conditional probability is a measure of the probability of an event given that another event has occurred. For example, the probability that any person has a cough on any day may be only 5%, but if we know or assume that the person has a cold, then he is much more likely to be coughing. For that reason, the conditional probability of coughing, given that the person has a cold, is 75% higher. The conditional probability is one of the most important and fundamental concepts in probability theory, but conditional probabilities can be quite slippery and require careful interpretation. To demonstrate how to obtain the equation for the conditional probability, first we must know what is the multiplication rule 2. That says that when two events A and B are dependent, the probability of both occurring is the probability of A and B, that is equal to the probability of A multiplied by the probability of B given A. We have 4 steps. The first step, in the first step we start with the multiplication of rule 2. So we have the probability of A and B is equal to the probability of A multiplied by the probability of B given A. In the second step, we divide both sides of the equation by the probability of A. So we get the probability of A and B over the probability of A is equal to the probability of A multiplied by the probability of B given A over the probability of A. In the next step, we cancel the probability of A's on right hand side of the equation, and we obtain the probability of A and B over the probability of A, that is equal to the probability of A multiplied by the probability of B given A over the probability of A. And in the final step, we commute the equation. So the probability of A and B over the probability of A is equal to the probability of B given A. So now we have derived the formula for conditional probability, and the final formula is the probability of B given A is equal to the probability of A and B over the probability of A. So now we can solve some problems. The problem that we are gonna solve says a math teacher gave her class 2 tests. 25% of the class passed both tests and 42% of the class passed the first test. What percent of those who passed the first test also passed the second test? The problem is quite simple. We know that the probability of passing the first and the second exam is 0.25, and the probability of passing only the first exam is 0.42. So we apply this formula in the problem, and we have that the probability of the second given the probability of the first is equal to the probability of the first and the second over the probability of the first exam. And we replace with these numbers here, and we obtain 0.25 over 0.42, and that's equal to 0.60. That multiplied by 100 is equal to 60%, and that's the solution for that problem.